So it was either make a really cool video last night or start out with a joke, an embarrassing joke about myself. So I decided to do both. Unbeknownst to me, before coming up on stage, I actually totally face-planted the bathroom door. So don't tell anyone. I don't want anyone to know about that. It's funny. I looked around trying to see if anyone saw me actually walk into the door, and now I'm up here on stage talking about it. So if I sound funny, it's because I have a fat lip from walking into the bathroom door. It's nice to meet all of you. Thank you for attending. Let's get right into it. So I am a recovering hacker of 20 years. Sorry, no rollerblades and trench coat. Greg went out looking for a hacker, and he was a little disappointed to find out that I don't wear hoodies. A majority of my career was spent penetration testing, and I lived in Germany hacking into connected cars. So yeah, it is a thing. I don't know if you guys have seen the YouTube videos, but actually taking control of the car over the internet and controlling the steering wheel and pushing the brakes and the gas, that is the thing. As a matter of fact, a lot of what we're going to talk today about are APIs, and that's how a lot of the connected cars communicate. So I did publish the first book on hacking connected cars, and it comes out this year, and yes, my hacker alias was Loki. I've done about 100 penetration tests in my entire career. And what we're going to talk about today is a new vulnerability research campaign that I conducted where I downloaded 30 financial services mobile apps and decompiled them to find out how systemic the problem is of how vulnerable these apps are. Raise your hand if you bank on your mobile phone. You've all been hacked. Just kidding. Yeah, so it's a thing now. As a matter of fact, I don't know if you guys saw the news recently, but the number of laptop sales have gone down while the number of mobile sales have gone up. It's because more and more consumers are preferring to bank and do financial transactions on their mobile phone. Okay, so you guys saw this during the video. I don't know if you guys know this or not, but more than 83% of the traffic reported by Akamai is API traffic on the internet. 83%. That means that 83% is not human to application traffic. It's application to application traffic. Next, a lot of in the beginning, a lot of organizations would build what are called monolithic applications. They were a single application that multiple development teams worked on. This model is now changed to microservices, and what's happening is these single monolithic apps are being broken up into these individual little services that all talk to each other over what are called APIs. When you guys log into your bank, when you log into your financial institution on your phone, that app is actually communicating with APIs. Now, one of the things that is really important for you to know about regarding this is what the heck an API is. Some of you are looking a little glassy-eyed probably from the carbs from lunch, so if this doesn't wake you up, I don't know what will. APIs are very easy to explain. It's basically like the whole electricity model where you have a bunch of different electrical generators, whether it's nuclear or coal generation, being provided to the electrical socket in your house, and it's connected to a toaster or a television. That is an API. It's a great example of an API. APIs are basically translators to the actual API providers, which is going to be the bank and other financial institution. Now, as Greg mentioned, this is my first time presenting on this, so I'm going to talk as slow as I can because I don't want to accidentally drop a bank's name. Considering the company I'm in right now. So what is API authentication? In order for you to understand these vulnerabilities, you need to understand how APIs authenticate with the back end. There's three types of authentication. There's basic authentication, which is username and password. You put your username and password in, and you authenticate with that back end, and it's called basic HTTP authentication. The second type of authentication is API keys. API keys is basically just an authorization header in the packet containing the actual key. The third is OAuth, which is basically I'm going to authenticate. That backend API is going to generate a token or a key and give that back to me, and that's how the app continues to authenticate, is with that key. Now, there's a fundamental problem here. and what my actual findings ended up being. So there's 3 things you guys need to be aware of. There's the access token, which is called a bearer token. There's refresh tokens, which actually create new tokens when those expire. And then the third one is JWTs. And that's basically roughly the same thing and can actually be interchanged with the other. So what is static code analysis? This is what happened. So I took an advanced REST client. This is basically a client that allows me to actually communicate with the backend API and actually send data to it. The screenshots you're going to see in today's presentation are the actual evidence from my findings. Okay, so what you're going to see here in the screenshot is the client of me communicating with, some of you may recognize them, AWS URLs. Okay, so a lot of the APIs, a lot of that traffic is actually being terminated and transacting through Amazon AWS. You guys can see there in the top header of the packet my bearer token that I'm passing and the resulting data from that token with that request. Here's another screenshot. And this is what is called MobSSF. A lot of you may be developers of mobile apps, and I think this is what's happening and what's causing the problem, is developers think that if you package it into an APK file, that you can't actually read it, that it's packaged, it's encrypted. It's not. It's compiled, it's packaged together, and you can decompile it. It took me 8 minutes to decompile each application. 8 minutes. And I was already into the source code, and I was already gathering API tokens and keys. Okay, so what you're seeing here is the interface for MobSSF. What it is it's literally a drag and drop of the APK file. And again, I've talked to some developers that didn't know you could get it off your mobile phone. There's actually a tool in the Google Play Store, believe it or not, that will actually called APK Extractor that will allow you to actually extract that APK off the phone and transfer it to a workstation for analysis. You're probably thinking, Alyssa, how did you do this? What tools did you use? I used grep. So for you nerds in the audience who like the command line and like Linux, I used grep, believe it or not, to search all of the uploads directories for all my financial apps for certain keywords. Then I used API Extractor, a cloud drive, and there's a client called Postman or Arc. Sorry, I move around a lot. The camera people are like, Alyssa, stop moving around so much. So those are the tools that I used for my analysis. Okay, so what exactly was my process? My process was export the APK off the phone, decompile the APK using MobSSF, using grep in the uploads directory, look for certain keywords like usernames and passwords, like credentials, like tokens and API keys. It was surprisingly quick and easy. Then I did an RTFM campaign. So I really didn't know what I was looking for. And one of the things that I found was shocking was a lot of these banks and a lot of these financial institutions, they'll publish their API documentation on how to actually interact with their API. So if I didn't really know anything about it walking into it, I could just go to the bank's website or go to the financial institution without creating an account, without authenticating, and just access the API documentation so I can better understand how it works. And that's exactly what I did. This is more evidence screenshot. You guys will see some things sticking out here like secret keys, session tokens, the actual URL of the server, more identity information, credentials. I found customer data in some apps. I don't know what the developer was thinking, but they took actual customer data and hard-coded it in the source code. I don't know if they were testing and they forgot about it. I don't know what happened, but I found PII. Okay, so this is a very big problem, and developers in the audience, you need to know that this is a thing and this is possible. So I'm here to explain that it is. Some of the findings were hard-coded AWS credentials, region credentials, secret key, access key, session tokens, hard-coded payment processors. So some of the financial institutions allow you to pay with the credit card with third-party payment processors. Now, some of those payment processors, as a matter of fact, a lot of them were part of the victim list, if you will. And so what I will say is this. They were great at securing their own data for their own financial institution, but they would hard code tokens and keys for the third-party payment processors in the app. So what was happening was, in some of the testing, and this is part 1 of 3 of my research, there will be 2 other research campaigns that will be part of this. This is only the first phase. In 2 and 3, I will be doing dynamic analysis. And what I found with some of the financial institutions is the developers were trusting that if you had an API session key, you've already authenticated. It's a logic issue. If the backend API server issues you an access token to communicate it after you've authenticated with a valid username and password, the API server saying, oh, Alyssa's got an API token and it's valid. She must have authenticated already. Logic flaw, right? So I could actually communicate with the backend data without authenticating. Open source intelligence in action. What you see up there is a screenshot from AWS. It told me exactly what to look for. I'm pretty dumb, actually. I always tell people perception over truth. I give the perception that I know what the hell I'm talking about. But the truth is I really walked into this having no idea what any of this stuff was, so I learned along the way. I didn't know what to look for in the source code for AWS credentials, so I went to Amazon, I went to AWS, and I pulled up the manual, and I looked it up. And it gave me the keywords to search for. So here, you guys will see in the screenshot that they're explaining how dangerous it is to hard code credentials and to only do it during testing. And they gave me the keywords because they give you the code to use. And then I went in here and did a grub searching the source code of these mobile apps and found those hard coded in the apps. I didn't even need to, you guys are probably like, oh, she must know everything about AWS. That's how she figured it out. Dude, I had no idea. Like, all I did was go to the manual and I RTFM'd. All right, I got 2 minutes. I'm going to try and hurry this up. All right, list of WTF findings. AWS credentials, private keys. Yes. As a matter of fact, authentication can also be done with private certificates. And guess what? Those private keys had no passwords. Security through obscurity. It's like, let's just remove the password and it'll foil the hackers because they'll be trying all kinds of different passwords and they won't work, not realizing there's no password. So I could actually import the private keys into my keychain, pretend to be your mobile app, and authenticate with the backend API server. Ooh, not good. I call it a woman in the middle attack. All right, private key certificates, hard-coded in the code, hard-coded tokens, access tokens used for authentication. Initial findings also included public-private keys. There was even a directory in one of the FIs called combined keys. I didn't even have to find them. The developer named the directory keys. Combined keys where all of the private keys were stored. There wasn't even security through obscurity in that case. It was like, hey, if you're looking for the keys, they're right here, right? Okay, so then realized that there were also Salesforce credentials. So a lot of these apps contained hard-coded Salesforce credentials. So I'm now coming up on 50 seconds. Other WTF findings include credential password URIs that contain the token in the URI, which will show up in the log files. Third-party integrations. This is only the beginning. I talked about that. Mission complete, static code analysis. Next is web form analysis. So you web forms out there that are using web-based forms, I'm going after you next. Third is not yet started, which is dynamic analysis. And that's it. This is my Twitter handle. If you want to stalk me, please feel free to do so. That is my mobile number. If you want to actually crank call me and you have that kind of free time, happy to accept your crank calls. And that is my Twitter and my homepage. Yes, I do have a homepage. I think they don't make me anymore. I think I'm the last one left with a homepage. Thank you, everyone. Have a great day. I appreciate your time.